So we're asked to solve this one by completing the square. First thing you want to do is we're going to subtract 46 from both sides. I'm going to subtract 46 from both sides. Now this is the same as all the other problems, it's just the zeros on the other side. So I'm going to say negative 46 is equal to x squared minus 14x. And now this is gone, but now I'm going to add something in here. Now what am I going to add? Well, remember, we're going to take that b term. So b is equal to negative 14. Okay. And I'm going to say b divided by 2, which is negative 14 divided by 2, which is negative 7. But then I'm going to take that negative 7 and I'm going to square it, which is equal to a positive 49. So I'm going to add 49 to this side, and then I'm also going to add 49 to this side. Now 49 minus 46 is just 3. Okay? And then over here I have x squared minus 14x plus 49. Now the beauty of this is that this is a perfect square. It's x minus 7, right? Now if you don't believe me, we could just multiply it out and double check. That's the beauty of completing the square. If I say x minus 7 times x minus 7, I get negative 7x here, negative 7x here, and then a positive 49 here. And if I add negative 7x plus negative 7x, I get the negative 14. Okay. And then over here, I still have the 3. Now we rigged the problem up so that way I can take the square root of this side. But whatever I do on one side, I got to do to the other. And remember, that's plus or minus the square root of 3. Now the square is undone by the square root. So then what I end up with is x minus 7 is equal to plus or minus the square root of 3. Lastly, I want to get x by itself, so I'm going to add 7 to both sides. Now 7 is a number, and the square root of 3 is a number. But we're going to leave this. There's a difference between exact value and approximate value. So we're going to leave this as the exact value, because if I plug in the square root of 3, I'll get like a crazy number, 1.73, blah, 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 blah. It's an irrational number. But as we get into high school math and college math, sometimes we want to just leave it as the exact value. So we'll just leave it like this. In other words, we don't want a decimal value. We can just leave the answer just like this. Now, of course, that's not cooperating with me. And that's our final answer. And I'll zoom out on that so you guys can see it a little better.